Ready to talk about spaghetti code today? Does anybody here write spaghetti code? Yes. All right, good. Intentionally? All right. Cool. All right, everybody else can go because we're going to talk about spaghetti code today. So as Spike mentioned, I'm an engineering manager at Doximity, where I build software to help doctors do their jobs better every day. And I am from New Mexico, where we fly around in wicker baskets that shoot fire. So pretty cool place. And I have a cute little tortoise. His name is Bunny Rabbit. Big thanks to my daughter for naming animals confusing names. So if anyone's looking for a low maintenance pet in about 60 years, he's gonna outlive me. So he might be available for you if you're interested in a tortoise. And also I've been working on software for the medical industry for just about 20 years. So all over the place, management software, scheduling software for hospitals, operating room monitoring software, and now kind of tools for doctors' everyday processes. So it's a cool industry to be in. All right, so we're gonna start with a story from Doximity. At the end of 2016, a few of us at Doximity started up a new Rails application, new microservice, and it was isolated from our main Rails monolith, and so that gave us freedom to iterate, freedom to do basically whatever we wanted to accomplish our goal, clear boundaries of code ownership, and our spec suite ran in under 2 minutes. It was amazing. So that greenfield application became more and more important and grew into one of the most critical applications in our ecosystem, with the number of contributors to our Git repo going from about a dozen to nearly 170. And that became a bit confusing. Our previously tidy Rails app became really difficult to work with, as active record classes and relationships were used in totally unintended ways. We constantly battled N+1s. Queries would run for 15 minutes, and we wouldn't know why they were querying what they were doing. And developers had a hard time figuring out where code belonged. New developers would come in and they would have a hard time figuring out where things were. So the question was, should we just fork off another microservice? Again, repeat the process. Could we ever get back to that bliss of a greenfield app again? And this is such a common experience with Rails applications that I've somewhat formulated this pattern of degeneration of a Rails application. First, we start to see that our controllers are bloated, so we refactor to thin controllers and thick models. Or we start there if we know better, if we've felt that pain before. Then our models start to get bloated. We identify God models, and we refactor to thin models and thick services, which sounds cool for a little while, until you end up with this giant bucket of intertwined general services that everyone uses and no one knows how anyone else uses. Does anybody else have a code base that sounds like that? Exactly. All right, here we go. And so we started to see bugs every time we changed our services just a little bit. And we started to go into lockdown mode, where we were really afraid to change anything because we weren't really sure if our specs even covered all the usages, all of the creative usages that all the other teams were using our models for. So the good news is that our apps that we love so much don't have to stay in a state of confusion. By taking some measured, intentional steps, we can dig ourselves out of the hole of complexity and coupling by just leveraging some simple tools to enforce code boundaries, leaning into modularization, and talking through method contracts, which we don't often do as Rubyists. We can return to not just one, but many lands of greenfield bliss, which sounds amazing. So packwerk is a tool that's helped us take an iterative approach to getting back to that greenfield bliss. And I'm going to give you some links to packwerk and some other resources later on. But essentially, packwerk is a static code analysis tool that detects private code access by modules outside of a package. So it prescribes a folder structure that's somewhat similar to the standard Rails application, but a little bit different. But it assigns privacy significance to certain folders. So what we did is we moved all of our code from the standard model view controllers and spread them out into a number of packages that were highly cohesive but loosely coupled. So everything inside of this app public directory, you've got a pack here called sales, and then reviews and social. Hopefully you can read some of this. So essentially everything in that public directory is accessible. If it's not in that public directory, other packages can't access it. So let's take a quick example here. Here we have two packages. We've got a sale package and a review package. And the sale model is not in the public directory, so it's not public. But we've got this review model over here in the reviews package, and it has a method called sales rolling 30. And it leverages the sale model and then calls finalize on it, where it's got a couple where clauses, and it's gonna get some rolling 30-day sales, right? This would be considered a violation, right? So it's reaching into a file that's located outside of the public directory. So what are some possible problems here? This seems like a simple thing that probably happens all the time. Well, what if the sales team, the sales application maintainers, never index the created at field, right? Works fine in development, might work fine in QA, and maybe even in your pre-production environment, but then you go to production, and all of a sudden you've got a method that's gonna take 15 seconds to complete, and you've got issues for your production users. What if the sales team wants to remove the finalized method or that scope, or change its meaning? Right? That's going to require a conversation with the review team. What if the sales team never reviewed this PR, right? Does this mean that every single PR needs to be reviewed by every single team? I know at some point when we had kind of this highly, well, it was kind of a mess, I was reviewing 85 PRs a month from other teams that were accessing our methods, and we still had things sneak in because not everyone can review every single PR. So the way we can utilize packwerk is to check for things like this, right? You don't have to review every single PR. It's good news. So we've got a bunch of command line tools with the packwerk gem, and the first one here we're going to talk about is packwerk check. So what this does is it scans through the whole code base and detects privacy violations like the one we just saw. So in this case, if we were to run packwerk check on our application here, we would see that we would come up with this message from packwerk check. It says we've got a violation in packs, reviews, spec models review, and we've got this privacy violation against the sale model in the sales package, and it says, hey, is there something you can do in the public directory that would work for this? And this is a check that you can run in your CI, right? So you don't have to review every single PR that comes through. It's good news. So having perfect little packages of code seems like it's amazing, right? It's well and good, and it would be a great goal to get to. But when you're staring at a 200,000 line code base that's really hard to work with, it's difficult to know where to start. It can be hard to get buy-in from stakeholders, it can be hard to get motivated when you don't have a plan between now and then, when you get that greenfield bliss again. So the stages I'm going to introduce here can be critical in building and maintaining momentum in a huge project like this. So here's a sneak peek of the whole talk. Here are the phases that I'm going to outline. So first of all, we're going to step back and we're going to look at what we actually have in our code base. We're going to examine our features. Next, we're going to just chuck files into packages. Then we're going to start declaring package dependencies, start writing those public interfaces, and then we're going to maintain it because it's so enjoyable to code in a repository that's easy to maintain. So let's start with the basics, which is not even in our code base. So firstly, I'd recommend that you get a lay of the land and figure out what your true feature set is. Work with your product leaders to understand how they view groups of features in your code base. And the emphasis really here is understanding how the business thinks about roadmaps, about planning, what language they use, and designing groups of your features, giving names to them, and using that for the basis of what your package structure looks like. And it's probably going to look different from what the engineers came up with or what the engineers would think of. So we used a process called event storming. We got our product leaders, our tech leads, and our directors together for a couple of days, and we talked about kind of the events that a user would go through as they're using our products, and put stickies up on a window and took pictures of those, and those became the folders that just like those directory structures that I showed in a bit or before here. So the next phase here is we use those feature sets from the planning phase that we just went through to create those folders and move the code into. When our team entered this phase, we just moved classes wholesale without changing any namespaces or making any refactorings and anything. And that really helped us move quickly with this process without getting bogged down in a lot of decision making. It may be worthwhile to examine whether the code's being used in the first place. So if it's not being executed, don't move it. Just delete it, and then you have less code to worry about. So packwerk uses YAML files to declare dependencies in these package.yaml files here. And I've got a sample one here. So that's where you would set up this array of dependencies. We held off on setting up our dependencies here. We'll get to that in a little bit. But we did add some metadata to our files to declare the owning team's Slack channel, as well as the code reviewer group. And this helped a couple different ways. One was it's a way for people exploring the code base to know exactly where to ask questions about this piece of code. And when you've got 20 or 30 packages that you're working with, that can be a pretty critical piece of information. Or for SRE, if you've got infrastructure people who might not work in the code every day, that'll be a good piece of information to give them. And then we also use that code owners piece to auto-generate our GitHub code owners file, which is super nice. So we moved nearly everything into packages. The way I looked at this was kind of a vertical slice feature. Thinking about if I wanted to delete this feature, what would I have to remove? So everything related to that feature, the models, the views, the controllers, the rake tasks, the database migrations, everything moved into that package. And what that does is it leads to a highly cohesive package where everything that's inside that package is related, but less coupling between packages. And the only code that we left outside of packages was application configuration code that didn't really relate to any single feature set. Or like, for example, our DB schema, that was outside of packages as well. We also added a README to each package directory. This isn't prescribed by packwerk, but we thought that it was a really good idea, where the purpose of each package was declared, as well as explaining the reasons why a dependency was present. And this helps later on when that assumption is no longer true. You can think about removing that dependency. And these package README files really helped to be clear on what belonged in a package, and equally important, what didn't belong in a package. So throughout this phase, everything will be a privacy violation. When you run packwerk check, you will get 450,000 violations because nothing is in the public directory. And this can be fairly daunting to look at. But packwerk gives us an out by letting us generate to-do files. What this does is it lists all the files and all the violations and tells packwerk, yep, we know about these things, we're gonna get to it later. So we can run packwerk update to-do, and this does the same code scanning that packwerk check does, but then it creates a YAML file that is, I call this like shit list based development. Like, this is our shit list, right? So as long as we get clear on at what point we can actually generate the shit list, then we can be relieved that, all right, there's nothing else, and now we know the unknown unknowns at this point. So when we were in this, we ran the packwerk update to-dos command for every single PR that moved files, chucked files into packages, and generated some massive to-do files. So again, you're going to have a ton of violations here. It's okay. We want to increase the number of files that are in our packages directory and minimize the files that are outside of our packs directory. So it's kind of a good sign. So now we've got the vast majority of our code in the packages, though all the coupling still remains. Okay, so phase 2 is going to be about declaring dependencies between packages. So we're going to start removing all of the dependency violations, but we're going to leave the privacy violations for now. So this is where you start drawing the coarse-grained lines between your packages. So here we've declared from our sales package in our package YAML file, we've set up that we've got a dependency on reviews and a dependency on inventories. And so if we were to have a to-do YAML file here, we would see that our dependency violations for those two modules would go away, but the privacy violations would remain since everything is still private. Okay, so as we're declaring our package dependencies in the package YAML files, we can run packwerk validate. And what this does is it makes sure that we don't have any circular dependencies. And this, again, can be introduced in your CI process so that you don't have to review every single PR that every single team puts into your code base. So if we have a circular dependency between the sales package and the inventory package, this is what's going to come up. So you should be eliminating all of those circular dependencies in this phase. And the challenge of this phase is that you're going to discover some really tough circular dependencies. And you might have to rethink how some of your code relates to one another. And in my opinion, this is where you're going to discover that you have an incredible amount of coupling between your features. So in our case, it helps to get through this phase by thinking of our packages as belonging to different categories. So we created infrastructure packages that handled things like general JSON parsing, messaging, instrumentation, and these generally worked with services that are outside of our application. And then we had common tooling. So if we had a base class, base active record class, or if we had some things that we wanted to do on front end that didn't relate to any specific feature, but could be used by all of them, that's something that we threw into our common tools packages. And then we had all of our features, like our profiles, sales, inventories that had the specific business logic. And both the common tooling packages and the infrastructure packages generally didn't have any outgoing dependencies. And so they were very independent of the feature set themselves. And this is very similar to domain-driven design architecture, if you're familiar with that, but it's admittedly a very generalized version, like DDD Lite, if you will. But it was helpful for us to think about our packages in this way. You may have some dependencies that can't be resolved by just breaking code down into smaller packages. So as an example here, let's imagine that we've got a user profiles package and a social package, and we've got a user in that one package, and then social has likes and comments, for example. This may or may not be a true situation that we ran into. So likes would refer to users because users make comments and likes, right? So now let's imagine that we have an additional process that needs to be executed whenever users are deleted. So we've got to signal to the social package that we've got to do some kind of cleanup, and these can't be handled by a simple foreign key cascade. So now we have a circular dependency because we're referring from one package to another, and then we need to signal to the other package that something's happened. So one way that we've found, and you can get rid of circular dependencies in a bunch of different ways, but you can think about using a pub sub system where you subscribe social to user profiles, and then user profiles can just signal, it doesn't really care who's subscribing to those events, and then that reverses the dependency using pub sub. We used a gem called Rails Event Store, which is a super lightweight event bus. So if you're ever looking for something to integrate like that would do lightweight eventing and you don't want to add a lot of infrastructure, that's a pretty good tool to use. Okay, so phase 3 is where all the hard decisions are made. So at this point, we have a pile of privacy violations, but we've declared all of our dependencies and eliminated all of our circular dependencies. So now we need to create these public interfaces that other packages can use. And public interfaces are really a stable contract, a code contract that other teams can depend upon, where changes to the public interface would have to be discussed, right? But teams can freely iterate on all the stuff inside without having to have discussions or doing code reviews extensively. So the internals of the package actually become that greenfield, amazing development platform, once again, where changes can be made freely as long as that public interface, that code contract is upheld. So here's an example of creating a public interface. You notice there's a lot of comments here. Sorry if the gray isn't quite as visible. We've got a lot of documentation here. And this is something that we decided as a team that every single public interface needed to be heavily commented because we wanted to make clear what the public interface did, what it didn't do, its requirements, side effects, things like that. And that really helps to make the contract crystal clear. And we also annotated all of the parameters using RDoc to put into writing what the expected inputs were. Duck types are amazing, but has anybody been bitten by a duck type that didn't work exactly as expected? So here we're really specific, where the days is integer, we've got a UUID that's being passed in, and then we've got this data object sale here that's being returned. And I'll talk about this in a little bit, but plain old Ruby objects can sometimes save the day. So preview of coming things here. One way that we found, one problem that we ran into is that it's really easy to leak all of our private methods or our private classes through return types. And so you'll notice there's this toData thing down here, and that's going to convert our active record objects to one of these plain old Ruby objects. So back to our violating class in review. So now we've got this public interface that we've discussed between the teams. And now we can convert the sales rolling 30 method to use sales.rollingDays, and it gives the number of days and then an item UUID. And now we can depend upon this public contract as being stable and solid, but everything inside there can change without us having to talk to the review team, which is fantastic. All right, so phase 3 is really tough, and our team has spent a lot of time in phase 3. You're just going to discover a lot of places where your code is really tightly coupled, your feature set is really tightly coupled. You're going to discover active record relations that are being misused in a lot of places. But we've identified some top areas where you're going to find privacy violations and found out with some strategies to handle those. So first of all, it's coupling in the database. So when you have foreign keys between tables, that's explicit coupling. And you don't often think about this as being a problem until another team runs a destroy all or a delete all on your database tables and then cascades all of your models because you've done a foreign key cascade delete. So that's an explicit dependency that you really need to discuss. Another piece is primary keys. And these can be kind of sneaky, actually. They're a bit sinister, but could become a problem if other teams are caching your primary keys. So let's imagine that you wanted to refactor the way a particular model was being stored, maybe from 1 table to 3 tables. So now your primary keys need to be regenerated, possibly, but they're being stored somewhere else. And so now you need a translation layer. It creates some really weird coupling. So that's another place that's you should watch out for. And the solution here is to really use UUIDs because you can regenerate those whenever you need to, and to consider getting rid of at least the constraints on your index for your foreign keys, and then using eventing or something else that's gonna prevent the cascading deletions from happening. So active record. Active record, the objects there are super powerful, right? So if you leak your active record classes outside of your public interfaces or as a public interface, there are a lot of problems that can happen. One, any other package can execute arbitrary queries against your data. So we're back where we're having that 15-second query again. They can join across models that maybe weren't intended to be joined, mutate data at will, delete data, all sorts of stuff can go wrong. So rather than exposing active record models, we decided to just expose plain old Ruby objects that only contain primitives. So that's what was returned by that toData method back there. And this virtually eliminates the possibility of n+1s by means of just like a single query or a join. You can still have n+1s where another team's calling your public methods in an n+1 fashion, but typically that's a little bit easier to detect. Another side note here is that sample tasks often reach into the private interfaces of classes, so that might be something you consider pulling in into the package to make things a little bit easier. Okay, so here we have an example of one of these data objects. So we've got an active record sale here, and then I've got this data object sale that includes active model, and it has a bunch of adder accessors. So that is just our plain old Ruby object, and then down in the sale active record, we've got a toData method that initializes one of these data object sales and passes to it just plain old IDs, UUIDs, and it determines what gets into that public interface. So from here, if we're returning these sale data objects, there's no possibility of querying into a child relation, mutating data, and it's this sort of abstraction that helps me sleep at night when other teams are using our public interfaces. All right, so specs. You're going to get a ton of violations in specs as well because we do crazy stuff in specs. FactoryBot is amazing, but it has lied to me numerous times and told me that what I'm doing is exactly like production and is totally valid. And then 6 months later, for some reason, all of my specs break. If your models are internal to a package, then specs outside of that package really can't make assumptions about how your data is put together. We should think about tests like that as being integration specs. So here we have an example of a refactored spec where rather than using FactoryBot to create up all these sales, which maybe our review team has no idea how those sales actually get created, but using this user orders item, it creates orders exactly how we would from, say, a controller or a service. And it can expect that those contracts are going to be upheld. It can then run its expects, and probably this is not going to break unless that contract is broken. Cool. So at this point, we've got our separate packages. Should be a high level of cohesion inside of our packages and a low level of coupling between our packages, meaning that the packages can change relatively freely of one another, right? Other teams, you can change up whatever you want as far as the internal implementations. Public interfaces should be commented up. We know where code belongs. We know where to find code. Your new developers will thank you because they can find what they're looking for. But phase 4 is really where the rubber meets the road because it's going to determine whether all this work that we did is for naught. So I have a few tips on maintaining your packages along the way. And first and most important is to run this stuff in CI because you're not going to be able to review every single pull request that comes through. You did too much work at this point to let it fall apart. So to let the robots do the work and figure out if you've got privacy violations or circular dependencies that are coming through. And I should mention that at some point, that shit list goes away, right? At some point, you're deleting those YAML files, and they should never come back again unless you make the conscious decision that, okay, we're going to take on this tech debt. Next is watching out for everything as public. I think this is probably the trickier one where perhaps people stop talking about why things need to be public or making useful abstractions. And everything is just like, well, let's just move it into public directory and then we can make these warnings go away. And it's easy to do, but eventually you're going to end up with that spaghetti mess again. So try not to do that. It really should spark a conversation about the usefulness of your abstractions. Are you giving other teams what they need in order to reach into your package and get what they need? Are you fully exercising the domain model? Does the domain model need to switch a little bit? Should some functionality be pulled into a package? This is all stuff that that we have to talk about as developers, as architects. One thing that I've seen is that returning an active record class is a way to speed this up. So if you really want to go back to N+1s and sleepless nights, make your active record objects public. Maybe there are some ways that people can manage them. I haven't found a way to do it yet. So plain old Ruby objects for me. Next is keeping your documentation up to date. Using that README file to declare why dependencies exist between pieces of your greater application, and revisiting those assumptions. This is a great place for new developers to come. They can scan through all of your READMEs and really get a strong understanding of what features are in your code base. Next is listening to feedback. And not just once, but checking back a bunch of times. Don't just ask like 2 weeks later, hey, is everything okay? And then just assume everything is fine. I think having that discussion over and over again, not just with developers, but your support team. So just 2 days ago, actually, I was giving this presentation at a company outing, and one of our service reliability engineers came up to me and said, well, it's really easy to figure out like what team to get to approach if we've got a stack trace. If we've got a long-running query, we don't always know like where that query came from, and so we've got to search through all these packages to figure out who we should talk to. And so we talked a little bit about doing some namespacing and making it just easier for them to work with. So keep talking about things, keep talking about the contracts as you develop your packages, and I think you'll end up with a really nice maintainable code base. And the next tip here is to enjoy it. All of us have probably like done the Rails new command and been like, oh, this is gonna be awesome, because now I can do whatever I want and there aren't gonna be any errors and my specs are gonna be amazing. So let's stay there, right? Like if you get there where you've got 20 or 15 or 5 packages and they're all really clear cut and it's enjoyable, I don't know, change things up, right? Think about how you can change your implementations to be better. Maybe you want to go from 1 table to 10 tables for something, or maybe you want to shift your storage mechanism to Redis. You can do that, right? If you want to throw all your data in an S3 bucket, you can do it. As long as you are maintaining those contracts, you have that freedom, which is super cool. All right, so here's the phased approach once again. And again, this is a long haul. If you've got a huge code base with like 170 or 15,000 contributors that are writing code, it might take a little bit of time, and you might have to carve out a section of the application to do this, to figure out how the process works for you. But figuring out what you have first is going to be super helpful. Don't make assumptions about how the packages are going to be set up based upon how you think about them as an engineer. Get input from product to understand what words they use, what language they use, because that's what gets echoed in all of our meetings, and new developers are going to hear that. And if it's the same, then they'll know where to go to look for a particular feature. Set up your package dependencies. Ask those hard questions. Why do these 2 features need to be so highly coupled? Can we separate them? Is there a way that we can rethink things? Develop really nice public interfaces that you talk about with other teams and that you maintain and grow as your application gets bigger and bigger. So many of us are working with spaghetti, right? Some of you raised your hands and said that you write spaghetti. I know I have as well. But don't give up. Sometimes we get 2 or 3 years down the line in developing a Rails application, and it seems like it's an untenable mess, and we'll never be able to untangle it, and it's just going to be like this for the rest of time. And that's where we get disconnected with our work. We lose the joy of what we do, and it becomes less compelling for new engineers as well, right? So don't give up on the dream of having clarity in your code base again. Your application doesn't have to stay confusing forever. You don't have to fork off microservices. I was talking to somebody earlier, and Ben was saying that he was going to have to fight me about microservices. It's not the only option, right? Rails engines is another way to do it, but it doesn't give the privacy scanning that we're seeing here. There's somewhere in between leaving a giant mess and just hitting undo and saying, we're going to take our toys somewhere else. um, so don't give up on that. And I think the goal really for all of us is to get back to the point where Monday morning hits and we're happy again. We're excited to build amazing software that solves hard problems. So don't give up on that. Cool. All right. Thank you.